Hello, and welcome to the T-Test and SPSS workshop, brought to you by the Graduate Statistics Studio here at Fresno State. Today we'll be talking about a specific inferential statistic called the T-Test. First, let's talk about when to use a T-Test. You'll use a T-Test when you have an independent variable with only two levels. Now, an independent variable is your variable that's manipulated, and the levels are the groups or conditions or treatments of that variable. Take, for example, I have class, and I have morning class, and I have afternoon class. I don't have any other classes. So I have two groups, the morning class and the afternoon class. And we also need a dependent variable to run a t-test. We have two dependent variables here. A dependent variable is just a variable that's measured. It must be a quantitative variable in order to use a t-test. So here we see what looks like scores on an exam for exam 1 and scores on an exam for exam 2. It ranges from 0 to 10. And if we just look through there, we see nobody got a 0. Now I'll show you the variables under variable view. We see we have the independent variable class, and we have two dependent variables, exam 1 and exam 2. Class is a nominal measure, nominal meaning that the values associated in this particular cell here, the cells in this group here, don't have any inherent value. A 1 doesn't mean 1 of something. A 10 doesn't mean 10 of something. It's just a label we use to identify a group. Whereas the scale measure actually tells us that a 1 does equal a 1. It means 1 of something. And a 10 equals 10 of something. That is how we can tell the difference between the two. You'll also notice that class has something under values. We see 1.00, comma, morning class. If we click on that, we see 1 is morning class, 2 is afternoon class. I've went ahead and coded the variables ahead of time, but this is just a recap. If you want to know more about this, you could check out our Introduction to SPSS workshop. There will be three t-tests that we will be talking about today. The first t-test that we will be talking about is the one sample t-test. And you use the one sample t-test when you have a population mean and you want to compare that to a sample mean. Now, this is slightly different from a z-test because with a z-test, you compare a sample to its population. Whereas with a one sample t-test, we're doing almost the same thing, except oftentimes we don't have the population parameters. We don't necessarily know the population mean or the population standard deviation. So we have to do a little bit of guesswork, or maybe we just base it off of some hypothetical value that we want. So first, let's take a look at data view. I want to see is exam 1, is the average for exam 1 a C level or higher? So we know that this ranges from 0 to 10. So a 7 would be 70%, which would be a C. So we want to know, did this particular group score a 70% or higher? So let's click on Analyze, Compare Means, One Sample T-Test. Now this window is brought up. We have our test variables, test value, options, and bootstrap. We want to bring over exam 1 because that's our variable of interest. And the test value, well, that's what we're comparing it to. We want to change that to a 7 because remember, we want to see if our particular group scored better or at a 70% level. So under options, we see confidence interval percentage. This is where you can adjust your alpha level. Your alpha level is a type 1 error, making a false positive. Go ahead and hit continue. Alpha is currently set at 0.05. If you want something more strict, you just automatically adjust the confidence interval because confidence interval is 1 minus alpha. So we have 1 minus 0.05, which gives us 0.95. We multiply that by 100, giving us 95%. When I press OK, a new window appears, and this is our output. We see the results of our t-test here are one sample statistics. Exam 1 had 56 participants, a mean of 5.9. Well, that already doesn't sound good, but let's see what the results show us. A standard deviation of 2.68 and a standard error mean of 0.35. When we look down here at the one sample test, we see our t-score is negative 2.889. Our degrees of freedom is 55, which is just the number of participants minus the samples. We only had one sample, so n minus 1. And we see significance, which is our p-value for SPSS. We see it's 0.006. Now, in order to find significance, our p-value needs to be at or below our alpha level. And if you remember from before, we set our alpha level at 0.05. So 0.006 is below 0.05. Now, that would mean that this is a significant difference. And a significant difference doesn't necessarily mean that, oh, our class did better than 70%. So what we'll need to look at is the mean score. We see 5.9. So what we actually see is that our class did worse than a C average. They had a D average. So how do we end up changing that in our class? Well, maybe we create a better way to study. We give them a study guide, or we teach better if possible. I want to identify the underlying cause of why our group happened to be worse. So what I will do next is an independent samples t-test. And you'll use an independent samples t-test when you compare two different group means. And you want to know, was there a difference between each group mean? If we click this star right here, it says go to data, and it brings us back to our data. I have our independent variable, morning class, and each level is morning class and afternoon class. So I'm noticing that scores in the morning class happen to be a little bit lower than scores in the afternoon class. But that could just be a pattern that I happen to be looking at. It might not actually be there. So we actually want to analyze it using an independent samples t-test. If we click on Analyze, Compare Means, Independent Samples t-test. When we click on it, another window appears. Our options is the same as the last time. Our confidence interval, we're going to keep our alpha of 0.05. This time we have test variable and grouping variable. So class is our grouping variable. That's our independent variable. We'll bring it over, but notice that there are two question marks. We first need to define the groups. Group 1, all SPSS wants to know right now is what values are we looking at? Because it's possible that we have an independent variable with more than 2 levels, but we can't run a t-test with more than 2 levels. So we want to tell SPSS group 1 is identified by 1 and group 2 is identified by 2. Now, if there was a third level, it would ignore the third level. It would only look at the 1s and only look at the 2s. Our test variable, we want to see exam 1. What we're looking at here is there a difference between the morning class's exam 1 average and the afternoon class's exam 1 average? Press OK. And here we have our t-test. Just make this a little bigger. We have our group statistics. Morning class, there were 28 in the morning class, and there were 28 in the afternoon class. The morning class had a mean of 3.75, while the afternoon class had a mean of 8.17. So right away we can see a very large discrepancy between the morning class and the afternoon class. Now, just because I see a difference here doesn't mean there's a significant difference. In order to know that, we have to look at our p-value. First, we'll go down to the independent samples test down here. Levine's test for equality of variances. We look at this one first because that looks at the standard deviations or the variances of our groups to see if they are similar enough to be compared. We want them to be similar because it's not fair to compare a square to a triangle. That's essentially what we're doing. We're looking at the distributions of each group, and we're seeing, do they match up enough that we could fairly compare them? So we want no significance for Levene's test because remember, Levene's test is looking at standard deviation. We see our significance level is 0.273, which means that there is no significant difference, meaning that the difference we see here, 1.6 versus 1.3, while that is a numerical difference, is not a real difference. This happened by chance. And by chance just means maybe one of the participants happened to be an outlier, or maybe one of the participants happened to, or a couple of the participants happened to just score low, or some of the participants in the other group happened to score really high or close together. There are a number of reasons for why this could have happened, but we want them to be similar to each other. Now, from t and beyond, that's our t-test. So remember, Levene's test is testing variances to see if they are similar. Because we don't see a significant difference there, that means we can look at equal variances assumed. Had we found a significance level below 0.05, we would look at equal variances not assumed. But again, because our p-value is 0.273, that means these are the same, which means we assume equal variances. We look at our t-score, negative 11.053. Our degrees of freedom is 54. But you'll know that we have 56 participants, but we have two different groups now. So that's why we do n minus 1 for the first group plus n minus 1 for the second group, giving us a total of 54. When we look at our p-value, it says 0.00. Now it's not actually 0. If we double click to activate this, we hover over the value and it actually says 1.7537e negative 15. What that e is telling you is exponent to the negative 15th power. So there are 14 zeros in front of this 1. So it's very, very small. It's much lower than 0.05. So what that tells us is that we see a significant difference between the morning class and the afternoon class. So you might be wondering, well, which class did better? Well, we just look back over here at the means and we see the afternoon class had an average score of 8.1 or 81%, whereas the morning class had an average of 3.7, 37%. So we know right away the afternoon class did much better on the exam than the morning class did. What we want to do now is we want to fix that problem. So maybe as an instructor, we go through and we do the better study guide. We read a couple teach books and we try and alleviate the problems that we may have in the morning class that we don't have with the afternoon class so that we can identify what those problems are, hopefully fix them with a intervention, if you will, to try and find a difference from exam 1 to exam 2. Because what we are hoping to have is that exam 1 might be bad, but exam 2 is much better. We want to try and minimize the distance that these groups have from each other because we want our teaching style to be effective. So now we've done our intervention and we want to see, is there a difference between exam 1 and exam 2? This is called a paired samples t-test, and we use it when comparing one group's mean in a pre-test versus that same group's mean in a post-test. We want to know, did the scores change from before to after? We want to see, is there a difference between exam 1 and exam 2? Did we teach better? Did this study guide help? Did our intervention change the results? Click Analyze, Compare Means, Paired Samples t-test. We see a different sort of window pop up. We have pair 1, variable 1, and variable 2. This time we're not bringing class into it. We just want to know, is there a difference between exam 1, bring that over to variable 1, to exam 2. and we'll bring that over to variable 2. Our options are the same as before. We are still going to use an alpha of 0.05, and we'll hit continue and press OK. Here we see our paired sample statistics. We have exam 1, which had an average of 5.96. If we scroll up, we can see that's the same average that we saw earlier. So back down to our paired samples t-test, and exam 2 had an average of 8.67. Both had 56 participants. The standard deviations are noted here. Here we have a paired samples correlations. We have exam 1 and exam 2. It has a significant correlation. Now you may be wondering, why did SPSS do this? Why did it give us a correlation? Well, it gave us a correlation because if we are looking at the paired samples t-test, these values should be paired in a sense that they should also be related to each other. And a correlation is just showing a relationship. It's quantifying a relationship. You can see more about that in our correlation in SPSS workshop. Now looking at the paired samples t-test, we see exam 1 to exam 2. We have a mean difference of negative 2.71429. Our average standard deviation, that's if we took these together, is 2.24. Standard error mean, 0.30012. Our confidence interval of the difference, so that is to say, we are confident that the difference lies somewhere between negative 3.31 and negative 2.1, while we got 2.7, somewhere in the middle. Our t-score was negative 9.04. Our degrees of freedom is 55. And you may be wondering, why is the degrees of freedom here 55, yet in the independent samples t-test, our degrees of freedom was 54? Well, with the independent samples t-test, we're treating each group independently of each other. So we do n-1 for one group, and we do n-1 for another group. However, with the paired samples t-test, we're using that same group, but we're measuring it twice. So independent samples t-test, 2 different groups measured once. Paired samples t-test, 1 group measured twice. And here we see our p-value, which is less than 0.001. So that's also less than our alpha level of 0.05. So that tells us that there is a significant difference between time or exam 1 and exam 2. And the difference we can see over here. We see exam 1 had a lower score than exam 2, which means to say that our intervention, our teaching method change, actually benefited our participants. They did better on exam 2. Now, it's also possible in this scenario that perhaps maybe the participants just finally reached a point where they understood everything. The morning class didn't quite understand things at first, but then we reached a point where everything clicked for them. That is also possible. So it's a little difficult to say that the intervention was the only thing that caused a change. It could have just been they got better over time, as a very reasonable explanation. Now there will be one more thing we'll look at. We see that there's a difference between exam 1 and exam 2, but we want to also know, did we affect both classes, or did we just affect the overall score? Because maybe the morning class got better and reached the level of the afternoon class, but it's also possible that the afternoon class actually got better from our change in our teaching method as well. So we're going to first click on Data, go down to Split File. This window appears, and we want to compare groups. We're going to bring over class and groups based on class. The reason we're doing this is because we want to see if there's a difference between morning classes, exam 1 and exam 2, and if there's a difference between the afternoon classes, exam 1 to exam 2. Click back to our data. We see down here it says split class or split by class. That tells us that the split class feature is on. If we click on Analyze, Compare Means, and Paired Samples t-test, we'll see that the window still displays the same information we had earlier. And because we have a split class, it will look at each one separately. So to break it down, we're not just doing one paired samples t-test right now. Well, it may look like we're doing one. When we press OK, what you'll see is it will run two paired samples t-tests. It will look at only those in the morning class and only those in the afternoon class. When we press OK, our paired sample statistics, notice there's a little bit more information here than the previous one. So we have our morning class. Here's their morning classes, exam 1 score, 3.7, and the morning classes after, or exam 2 score, 7.8. So we see, okay, there's a mean difference there, but is it statistically significant? When we look down at morning class pair 1, we see, yes, that is a significant difference. So these two classes are significantly different from each other. We look at afternoon class, we see 8.1, 9.5. Those are really close together. It may be that this isn't a real difference. Maybe this happened by chance. But when we look down at our afternoon class, go all the way to the p-value, we see there is a difference. So what this tells us is that the afternoon class also benefited from our change in teaching method, and the morning class benefited as well. Now, there is one other t-test that we could run, and that's to run an independent samples t-test on the difference between exam 2 for group 1, the morning class, versus group 2, the afternoon class. But I believe you have enough information to do that on your own, and I highly recommend you give it a shot. The best way to learn SPSS is to practice, to just mess around with it. Don't be afraid of breaking it, because it'll take a lot before you can actually break the program. And that's been the T-Test and SPSS workshop. Thank you for joining.